Let's start. So, this is today's outline. So first we will go through some announcements, and then we will have a quick look at the roadmap of what we have covered and what we will be covering in the rest of the course. And then we will look into how do we modify data with SQL, and we will look into some single table queries and views, some concepts of views as well. So for announcement 1, so in the last week we have done the quiz 1, so please try to stay updated. We are sending emails, we are sending web CMS notifications, and I'm doing some announcements at the start of every lecture. And still about 50 students didn't submit their question at all. And a good news for all those who have submitted their questions, so most of the students got full marks. And none of the students who have submitted their answers got a 0 mark. That's a pretty good news. And the average score is a little bit higher than the previous terms. So good job, class. And please do take note that quiz 2 has already started. So the deadline, if there's no changes, it should be this midnight this Friday. So please make sure that you do your quiz 2. And that's the first announcement. And the second announcement is that we are releasing an assignment 1 soon. So please stay updated. We will be sending emails, we will be putting notifications on web CMS, and I will make announcements during the lecture, but please just stay updated. And the submission of this assignment 1 is by the end of week 5. That's before the flexibility week. And I will be discussing about the details of assignment 1 in our next lecture. So that's all about the announcements. And now let's move on to the roadmap and recap. So let's have a quick warm-up of what we have learned, what we have covered. So in the last week, we have covered entity relation to relational mapping, and how do we map entity relation diagram into SQL. So first, for entities, how do we map from ER to relational? How do we map strong entities? It's very simple, right? We just convert the entire entity into a table. For weak entities, we need to have a separate table, and we need to set up the foreign key correctly for weak entities. For relationships, we have covered many-to-many relationships, and that's the easiest one to be converted, because we just need to put in all the primary keys participated of the participants of each for this relationship. And for one-to-many relationship, we need to consider putting the attributes of the relationship into one of the tables of the entities. And can you think of which entity table should we use to hold the attributes of the relationship here? Is it on the one side or the many side? Yes. The attributes of the relationship should be associated with the table of the entity on the many side of the relationship. And for one-to-one relationship, we have covered, we can either assign the the attributes of the relationship to either one of the participating entity here. And for all the three relationships we just covered, they are all binary relationships, which means that only two sets of entities are participating in that relationship. What about a multi-way relationship? So how do we determine the keys for this type of relationship? So for many-to-many relationship, it's easy. We just collect the union of all the primary keys of the participating entities as the primary key for this relationship. If there's an arrow in this multi-way relationship, we just collect all the primary keys from the entities without an arrow as the primary key for this relationship. So this is how we map relationships. And for attributes, we have covered how do we map composite attributes and how do we map multi-valued attribute. For composite attribute, we can just flatten the attribute into multiple columns of the table. So that's straightforward. For multi-valued relationship attribute, we can convert it into a weak entity to capture the behavior here. And we also covered how do we map subclasses. We have three types of styles. The first one is called ER style, which is to create a separate table for each one of the entities inside this inheritance chain. And for each of the subclass table, we inherit. We don't include the attributes of the superclass. We just put a foreign key pointing to the superclass. So that's how we do ER style mapping. And for all style mapping, what can we do? What's the difference? The difference is that although we are still keeping a separate table for each one of the entities, we treat them as separate tables. So each one of the subclass will have all the attributes as columns. So that's how we do OO style mapping. And finally, what we can do is we can do single table style of mapping. So that is to put all the columns, all the attributes into table columns, and we allow some of the columns to be null. So that's how we do single table style of mapping. So remember that just now what we have covered is simply from entity relationship to relational modeling. And if we really want to map it into SQL, we need to think about the constraints. We need to think about how do we determine the foreign keys and the primary keys. So that's about the mapping. So this actually, what we have learned, this type of knowledge tells us how do we design a database. So what we do normally is that we start from an ER diagram, and then we convert this ER diagram into a relational model and SQL. So that's how we do it for practice. And we also have covered some basics about SQL. So we covered the syntax of SQL. We covered how do we describe or how do we show the constants like strings or numbers. And we covered what are the identifiers and what are the keywords. There are some preserved keywords. And we have also covered some operators. For example, we have covered arithmetic operators, which are similar to other programming languages. And we also covered some string matching operators. We have two types of string matching operators here. So The first type is to use some wildcard characters to do this string matching. And the second type is to use regular expressions to do string matching. And regular expression is much more powerful. And there's a special case for the operators, and that's the null value, because most of the operators are null preserving, which means that if one of the operands is null, the entire result becomes null. However, there's a special case for this special value, that is the logic operator. So do you still remember the table, the big table of logic operations, like true or true results in true, true or false results in true as well, and true or null results in true as well. So as far as the operator is or, and there's a true, the result is always true. What about true and false? False, yes. False and false. False, of course. False and null. False, false as well. So as far as the operator is and one of the operand is false, the result is always false. What about nor or nor? Yes, nor. The result is nor. Now and nor. The result is null as well. So this is a special case because if only if both operands are null value, the result is null. So it's unlike other operators. So this is how we deal with logic operators. And we also covered the SQL data definition language. So first we have covered how to define a schema. So a schema is like a table header, which contains of the name of the table, the attributes contained in the table, and the domains or constraints of the table. So the tricky thing here is about how we deal with primary keys and foreign keys. And actually, primary key indicates some constraints, actually two constraints. So what are the two constraints indicated by primary key? Yes, unique and not null, which means that the value of the primary key should be unique within the entire column, and it shouldn't be null. So that's the constraints indicated by primary key. And other than the predefined constraints for Postgres, we can also have some customized constraints using the keyword check. So remember that we cannot, Postgres doesn't allow us to put subqueries in checks. And although the semantic of the code is not changed, we should put and give a name to the constraint as a best practice here. So this is about how we define a schema, and here are the two things you have to keep note. And after that, we also covered how do we manage a database system, how do we create and drop databases, how do we create, alter, and drop tables. So this helps us to know about the basic SQL operations. And remember, SQL is made up of several sub-languages. One of them is the data definition language we have covered last week. And in this week, we will be covering data update language and data query language. So this is the roadmap, and this is where we are, and this is what we will be learning. So now let's go through the data update language. How do we do modifications in SQL? So in last week we have covered how do we create, drop, or change the table. And there are more statements for modifying the table content. So there are basically three types of statements. The first one is insert, which allows us to insert new tuples into a table. And the second one is delete, which allows us to delete tuples from a table. And the third one is update, which allows us to modify the content of a table of existing tuples. So remember that we have defined constraints when we define the schema of the table. And these constraints are applied when we do the following three types of statements. And we will see how the constraints are applied later. So first, let's look into insertion. So insertion allows us to add new tuples. So we can have three different types of insert statement. The first one is just to insert into a relation, into a table name, and with some values. And the second one allows us to describe what are the attributes of the table. The third one allows us to insert multiple values. And the first two are used to add a single tuple into the table. And the last one is used to add multiple tuples in the same time. So let's cover them in details. So inside the first type of statements, the values, because we are not specifying the attributes after the relation name or after the table name. So it means that the values here must contain all the attributes of the table. So it should be in the same order as appeared in the schema. And there's a special case that is default. So if we have specified a default value in the table schema, we don't need to insert a value for that attribute when we do this insertion. So that's a special case. For the second type of insert statement, we can specify the attributes of the table. And the values here, the order of the value must match the order of the attributes we have specified in the statement. And for those attributes which are not specified, they are assigned with a default value, or just now if we don't do anything. So that's the second type of insert statement. And let's do an exercise here. So actually, this exercise is quite interactive. So I have fixed all the links here. So if you click on this link, you can actually go to the exact example on one compiler. So if you are watching the recording, you can do it on your own laptop. And if you are here in this classroom and you have brought your laptop or even your iPad, you can use your own iPad or you can use your own device to try out the examples here. So in this example here, we have two tables. And actually, the contact table is not used in this example. So let's try to do these. Quickly go through all these questions here. So in this table, we have 4 attributes. The first one is ZID, and ZID, the constraint of ZID is a customized validity check, which is to check against a regular expression. Actually, this regular expression makes sure that every ZID is started with a character with letter Z and 7 digits. So this is the validity check for ZID. And for name, the only constraint is that it's not null. And for row, we have a default value, which is lecturer. So if we don't specify the row of a tuple of an employee, it is set to be lecturer. And we also have an attribute called introduction or intro, and which has no constraints at all. So first, let's try to populate the database. So what we can do is we can comment out these 2 insert lines. So if we don't change anything, the result will be empty because we just created an empty table. So nothing is inside the table. And let's try to insert Clark and Dave into the table. So as you can see here, we are using the first type of insert statement. So we don't specify attributes after the employee, the relation name, after the employee table name here, and which means that it will accept all the attributes as in the values here in the order of how we define the schema. So if we want to insert like this, the first value must be ZID because it should follow the order of the schema here. The second one should be name. The third one should be row. And for Clark, we don't have an intro attribute in the values here, which means that the default behavior is, since we don't specify the default value in our schema, so the default value inserted by the database system is null, as you can see in the result. For Clark, the intro is null. For Dave, we have inserted every attribute. So as you can see, it is here. So let's look into the first question. So what will happen if we just insert Bob like this? So is there any error with this insertion here? Yes. First, the primary key is not unique, and we have to change the primary key. And what else? If we change the primary key to a unique one, what else error do we have? Yes. Because in this type of insert statement, if we don't specify the values after the relation name, after the table name, so the values will follow the order of the schema definition. So here, if we insert Bob like this, the third field will be inserted into the row field. and it is wrong. This one should go into the introduction field. So let's see. As you can see here, if we just do the insertion like this, the introduction will be inserted into the row column here. So this is wrong. This is wrong. So how do we fix it? So what if we just want to add Bob as a lecturer without specifying the row attribute? What to do? What's the correct statement here? Yes, it has a default value, so we don't need to worry about that. But how do we do that? Actually, we can use we have mentioned 3 types of insert statements. What we can use is to use the second type of insert statements here. The second type here. We can specify the attributes that we want to insert into. What we can do is we can do insert, we can into employee, you can do it on your own device. And what we can do is we can actually copy and modify this statement. So instead of just putting a relation name here, what we can do is we can specify the field. We can specify that ID, name, and intro. So in this case, we don't need to follow the order of the schema definition. And let's see the result. So now you can see we didn't specify the row attribute, and Bob is automatically assigned as a lecturer. And the ordering here doesn't matter. And let's move on to our next question. So what if we want to insert Clark and Dave in one statement? What can we do? Yes. We can just use the third type of insertion here. What we can do is we can insert into employee with values of two tuples. So this is how we do it. Oh, sorry. Value list out. So value list should be of the same length as prompted by the system. So Clark is a lecturer. Clark is a lecturer. So we can use the third type of insertion statement to insert multiple values. And we can assign attributes here in this type of statement as well. So this is how we do it. And the last question is not related to insertion, but it's just a quick recap of what we have learned. So what if we want to add a column to the table? What if we want to add an email column to the table? So without modifying the create statement. So which statement should we use to modify a table header? Yes, outer. So if we want to add a new column to the table, what we do is we do outer table. Note that the case doesn't matter for the keywords here, so SQL is case insensitive. Outer table employee, add a column called email, and we can add some constraints for this. Let's say we add an email validity check. So what is the regular expression for mapping an email, for checking the validity of email? It's actually not in any of the notes. It's not part of the course. But what I will show you is how do we use Google, because I just mentioned in our last class, you have to Google a lot when you learn this course. You have to Google a lot when you learn programming. And you can't remember everything. For example, here, for checking whether an email is valid or not. So what we can do is we can just use any of your search engine and regular expression email validity. So some people, they like to ask an exact question to the search engine. So like, how do I check the validity of an email address with regular expression? Actually, if you have learned about how the search engine works, you don't need to type in a whole sentence, because it will distract the search engine. So what you do is you just key in some keywords. You just put in some keywords. You don't need to make it a valid sentence to search. So the more blurred, the more fuzzy you search, the better result you could have in the end. So as you can see, if we just do this, so the first one, normally the first one is Stack Overflow. And if you are searching with the new bin, you can also get some help from the AI assistant. So you can see here, actually there are many different types of checking the validity of an email with regular expression. So as you can see here, it could be as long as this. So you can't remember that, and you have to learn how to use Google. And you will be using it a lot when you go to work. So let's try to copy this one here. What we can do is we can just copy and use it. Of course, this is a simpler one. So what we can do is we can just use it. And this is how we alter the table here. Sorry. Syntax error near constraint. Let's just remove this first. Oh, because we haven't specified the type of. We need to add a domain of we can just create it as text. So I think the backend server is running, but we are actually changing the table header here. So So this is, just now I have showed you the examples of 3 different types of insert statements and how do we alter a table header. And now let's continue our journey today. So sometimes, even though we can insert multiple tuples with one statement, it's not very convenient for us to do so in real world because normally the data is not, before they are stored in the database, they might be stored somewhere else, or they might be even produced by some other programs. So what could we do with this situation? So actually a lot of database management systems allow us to do bulk insertion. So this is how Postgres allows us to do bulk insertion. So this command is actually from the documentation of Postgres. And how do we interpret this command? So the command name is called copy. So we should specify a table name as an operation of this command. And whenever you see a square bracket here, it means that it is optional. So it's optional for us to specify the column names here. And from is actually, you can see there's no bracket around this from here, so it is needed. So from, we can actually from 3 different sources. So the curly bracket here means you can select either one of them, but it shouldn't be empty. So we can specify a file name. So we can actually import data into the database from a file, like a CSV file. And we can also insert data from the output of a program. So we can specify the command for invoking another program. And the produced result by that program will be inserted into the database. And we can also specify to grab data from the standard in. So standard in is actually a special file descriptor used in the Linux system. Actually, it's just like you can key in something from your keyboard, from your. That's how standard in works. And you can also add some other statements, but those are all optional. So this is how we do bulk insertion with Postgres. You can try it with your own SQL server you have set up. And the last command statement for data manipulation here is deletion. So deletion allows us to remove tuples from a table. So the delete statement contains 2 clauses. The first one is delete from. So it specifies the table we want to apply the deletion to. And the second clause is the where clause, which specifies the condition for filtering, for grabbing the tuples for deleting. So it actually, what it does is to just remove all the tuples that could satisfy the condition specified here. And there's a special case. So if we want to delete everything from a table, we can just delete from that table. We don't specify the where clause here. And it actually equals to, these 2 statements are equal to each other. So if we just omit the where clause there, it's actually we are true, so the condition is always satisfied. So let's have a quick look at another example here. So in this example, we are reusing the table we have created just now, and we are populating the table with Clark, Dave, and Bob. So this is how the table looks like for now. And the first question is how to delete all tutors. How do we delete all tutors? What's the statement here? You can also try it on your own device. So what we can do is we just delete. Note that the SQL statements are case insensitive. You can delete from employee where. So since we are deleting tutors, so we should specify the row here in this condition, where row equals to tutor. So this allows us to delete all the tutors. So you should see that we should watch out for the changes of the output here. So as you can see, we have deleted all the tutors from the table. So this is how we delete all the tutors. Let's have another example here. So how to delete all the people with whose ZID starts with digit 1. We need to do string matching. We could use the wildcard string matcher or the regular expression. And personally, I prefer regular expressions. So what we can do is we can delete from employee where ZID. So instead of equals, we use the string matching operator here, where ZID matches the following pattern. Starts with D, starts with letter Z, and 1 dot star. So this is the regular expression for ZID. Starts with digit 1, and let's just try to run it. This should allow us to remove Clark and Bob. Let's see. So now you can see only Dave is left here. So this is how we delete. We can use all kinds of operations or operators in the where clause in the condition there. So how do we delete everything in the table from the table? What can we do? Yes, what we can do is we can delete from employee with no where clause. So this allows us to delete everything. And remember, in our last lecture, we have covered another statement that is applied on the table level. So not drop table. That also deletes the table header. So without deleting the table header, but we just want to delete all the contents of the table. Which statement can we use? Which statement can we use? Some of you may have the answer. Does anyone know? Yes, truncate, you got it. So what we can use is truncate. However, truncate won't work directly here. And that's because we have a second table here, and it is used in this example. So for truncate, because contact is using employee that ID of employee as a foreign key inside the contact table. So if we use truncate to delete the data inside the employee table, it may affect the data integrity of this contact table. Because if we delete an employee, and if there's a contact related to that employee, we will have some problem. So what we can do is we add a keyword cascade. That allows us, this time it works. So the keyword cascade will help us to delete all the related data tuples in other tables, in the associated tables of the table we are working with. So in this case, we need to do truncate and cascade. And that's the example for deletion. And if we think about, and that's how deletion works. And if we think about the mechanism of deletion in the DBMS, so how does the database delete a filter and delete data? Because we can have a where clause to specify the type of data we would like to delete. And how does the DBMS actually works? There are two types of semantics here. The first one is we can just iterate through the entire list of tuples. And for every tuple, whenever we encounter a tuple, we check it against the condition there, the where condition. And if it is satisfied, we just remove that tuple from the table. That's the first method. The second one is instead of dropping the data item in the first iteration, we do it with two loops. So in the first loop, when we loop through all the tuples, we just take note of the tuples which could satisfy the condition we have specified. And then in the second loop, we delete all the tuples we have taken note of. So these are two different styles or methods for doing the same thing here. But there are differences. There are differences for these two types of methods. So actually, in most of the cases, they do the same thing. You may think, okay, it doesn't matter if I just drop it on the go or if I just drop it entirely after I have grabbed all the matching tuples. What's the difference here? So here is an example. So sometimes we could have subqueries in the where condition. And in this case, in this example here, we are deleting from the employee table, and where the condition is a subquery, and this subquery means if the number of employee is larger than 1. So if there's more than 1 employee in the table, So this makes the difference here. So if we remove data one by one, so there is some time that the table will be down to one item, right? One tuple. So in that case, if we do it with method 1, method A, there will be one tuple left in the table. And if we do it with method B or the second method, there will be nothing left because it will check the condition at the start and then remove everything that satisfies the condition. So if there are more than two employees, more than one employees in the table at the start, this condition is always true for all the tuples inside the employee table, and it will remove everything. So in this case, so this example shows that normally method B will remove more data items than method A. But you may wonder which method does Postgres use? So let's try it out. So in this example here, we are using the example command inside the slide. So we try to. So the condition here is whether the table has more than one data item. So whether the table is made up of more than one rows. So in the first method, there will be one item left. If Postgres is using the second method, everything will be deleted. Let's try it out. As you can see in the result, we have deleted 2, and there's nothing left in the table, which means that Postgres is using method B. So it will use 2 loops to delete data. So it will first go through the entire table, take note of the tuples that could satisfy the condition specified in the statement, and then it will loop again and delete all the tuples it has taken note of. So Postgres is using method B here. And that's all about deletion. And we can have a 10 minutes break. And after that, we will come back and learn about how do we update data. So you can grab some snacks here, and please keep in mind the rules in this lecture theater.
Like this question is about the total participation of like 2 entities. And like I do the practice too, and I encounter problems like I need to like write down the reference for both entities, right? For this like description, like both entities need a total participation.
All right, let's start the second half of today's lecture. So just now we have covered how do we insert and how do we delete into and from a table. And now let's see how can we update existing rows or tuples in the table. So the update is very similar to deletion. So it's actually involved in three different clauses. The first one is update. So in this update clause, we define the table name to be modified, and after that we have a set keyword here. So it is followed by a list of assignments. So it's about the actual update we would like to do, and we could also have a where condition like the deletion statement. So the assignment may assign constant values to attributes, and that is quite straightforward. We just modify the constant value for particular attributes. And what we could also do is we can use existing values to calculate new values and update and use the calculated value to update the table. So in this case, if we want to reduce the price by 50%, this is what we can do in this example here. So let's try to do some exercise with update. So let's reuse the employee table we have been working with. So in this table we have inserted three different pieces of data. So Clark, Dave, and Bob. And let's go through all the questions here. So the first one is how to change the introduction for Bob. So how do we change? You can do it on your own device. You can do this. So what we can do is we can update and then specify the table name, update employee, and then set. Set is followed by a list of assignments. And here in this case, we want to update the intro attribute or the intro column of Bob. So what we do is we set intro to be, let's say, Bob is an admin. Because currently, since when we insert the data, the information for Bob, we don't specify the intro, so it's now here, and we can just set it to be some string. And since we are only updating for Bob, so we need to specify the condition. We need to get the specific tuple we would like to update. So what we can do here is we should select the tuple for Bob, where name equals to Bob. So let's see what's the difference here. So as you can see, we have updated the existing table here. We have updated the intro for Bob. In the second exercise, let's see how to change both the row and the intro for Bob. How do we update two attributes in one statement? So this is what we can do. So we need to modify the row and intro. We can set the intro to be something. Let's say we would like to change the role of Bob into lecturer, or maybe into tutor. Bob is a tutor. So we can add a list of assignments separated by commas for the set clause. As you can see here, we have changed the role and intro for Bob here. And let's move on to the third question here. So how do we change the role of all employees whose ZID starts with 1 into lecturer? So in this case, Clark and Bob, their ZIDs are starting with the digit 1. So we would like to change them into lecturers. So what we would do is we can update employee set. Since we are changing the role here, so let's change the role into lecturer. And the key here is about the where condition. And remember, we have done the check of the matching of ZID with a regular expression pattern. So this is the correct pattern we should use. That 1 dot star. And this will help us to change all the employees whose ZID starts with 1 into lecturers. As you can see here, we have modified Clark and Bob, but since Clark is already a lecturer, so it's not, the change is not reflected, but it's actually updated. So this is how we update all the employees with certain properties. So the last question is, what will happen if we don't have the where clause?
Will it set it to like every single item?
Yes. So the default behavior of having no where clause is the same as where true. So it's like all the items will be updated. So let's try it. So let's say we would like to update. Let's just copy our previous statement. Let's just update employee set role to be lecturer. What will happen is all the employees will be affected. So no where clause equals to where true. So it's the same as deletion there. So this is how it works. So you should be careful for dealing with the conditions here. And let's move on. Just now we have covered how do we do data modifications in SQL, and now let's move on to how do we fetch data from the table. So remember, the full name for SQL is called structured query language. So query is the keyword here. A query is actually a declarative program that retrieves data from database. So it is declarative. The keyword declarative means that we don't tell the database management system how do we grab the data. So it is managed by the database management system. What we need to do is we just describe what we want. So this is why it is called a declarative program. So normally queries are done in two ways in relational database management systems. So the first one is we can do it interactively and using some shell. So for example, you must be familiar with PSQL, and you can also interact with DBMS with a program. You can write some Python scripts. You can use whatever programming language actually you like to interact with the SQL database. And since we only need to care about what kind of data we want, we only describe the data we would like to have. So we don't care about how to actually collect the data. Actually, it is handled by the DBMS, and it is following the relational algebra, and which will be covered later after we have learned all the basics about SQL. So SQL query language consists of a sequence of clauses. So the first one is select. So select is followed by a list of relations or projections. Is a list of attributes actually, or projections of attributes. And from is followed by a list of tables. And similarly, we also have where condition here because we would like to filter the data we would like to fetch. And we could also have group by, is to group the data we have fetched by certain attributes. And the last one is having. So having is applied on the groups we have been using. So the where, group by, and having clauses are all optional here. And the result of a query is a relation. So remember the definition of relation is a set of tuples. So the result of a query is a set of tuples. And typically is displayed as a table like what we have seen just now with all the examples. So the result does not need to have all the attributes of the table we have queried. So it could be as simple as just one row, one tuple with only one attribute. So if you consider it as an Excel table, it's just a cell. The result could be just a single cell. So this is here are the definitions and concepts, and here are more definitions and concepts. So functionality is provided by SQL. So there are 4 basic types of functionalities provided here. So the first one is filter. So we can actually extract attributes from tuples, and we can filter the exact tuples we would like to have. And the second feature here is combining. So we could query from multiple tables, and we will cover that in our next lecture. And the third functionality here is summarizing. Remember, there are some operators that are aggregations which will work on the entire column of data instead of rows of data. So, for example, we can calculate the average value for an entire column. We can also calculate sum. We can also count the number of rows for a column. So SQL allows us to do summarization with aggregations. And there could be set operators. We could use union, intersection, and difference to work on the results of queries. And there are also some more functionalities. For grouping, it's like we can form subsets of tuples sharing the same property. So this concept could be a little bit tricky to understand, but we will show you with some examples. And we can also do group filtering. So after we have grouped the data, we can filter the groups with the having keyword. And the last functionality provided here is renaming. So we can use the keyword as to name some of the attributes. So naming is actually, it doesn't affect the semantic of the query you have written. It will only improve the readability of the query. So this is all about the functionalities, and let's do some exercise. So this time we are using a different set of tables. So we have 3 tables here. The first one is student, the second one is course, the third one is enrollment. So basically it keeps the record of the enrollment situations for students and courses. So for student, we have the following attributes. We have the student ID, which is an integer as the primary key. And we have first name, last name, email, and year. So year means which year is the student in. So this is the student table. And we will be working with sorry, I don't know why the example was messed up. And if it messed up for you, you can always copy the SQL from the slides into one compiler. Sorry about that. And now we only need to deal with one table here. So the table is called sales, and it has 3 attributes. So the first one is product, the second one is price, the third one is quantity. And you may notice that we don't specify a primary key here, and it is actually allowed because Postgres will automatically assign an ID, unique ID for each one of the tuples here. So what we do here is this sales table keeps track of the product we have sold, the name of the type of the product, and the price of the product being sold, and the quality of the quantity of the product sold at that particular price. So this is how we interpret this table. As you can see, we have populated the table with some information here. So the first question here is, can we, sorry about this. Can we do this? Can we select everything from the sales table and group it by product? Can we do this? Does SQL allow us to do this? So remember, group by is to group tuples or rows according to certain attributes. a lot of you look confused. So actually, let's try it. If you are confused, you can just try it. It is actually not allowed, as you can see here. So what it tells us is sales.price. The price column must be appears in the group by clause. So we can actually group by multiple attributes. And the reason of not allowing us to do it is because we have to use aggregate operators for all the attributes which are not used in the group by clause. So if an attribute appears here after select, and it is not used by group by, it should be used with an aggregation operator. So it is confusing. It's quite complex here. So let me show you a concrete example here. So what we can do is instead of selecting everything from sales, what we can do is we can use sum, or we can use count. And let's see the result. Maybe to make it look better, we can say select, and we can also select product and display it. So as you can see here, we are actually grouping the data according to the unique value of product. So this is what groups by gives us. So groups by gives us groups of data. However, in order to display them, we have to apply some aggregation operators on the rest of the attributes in the select. Otherwise, it's not meaningful to display. Imagine instead of displaying the count here, if we just display the type of the product here. So or if we just display the price here, it's meaningless because the group by operation is actually aggregating data into different groups. So if we just display price, if we just select price, it cannot be displayed. It is not meaningful. So that's why we need to apply some aggregation operators that works on columns of data to be used together with group by. So this is the thing. This is what we should do here. So here's another example. So in this example, we can select the product and we can select sum of price times quantity as the number of total sales. And we can group it by product. So this will give us the total amount of money we have earned by selling each one of the product. So this is the example here. So you can just remember that, okay, group by almost always appears together with aggregations. So that's the thing here. So some of you are still looking quite confused, but you can try it. You can try it with your own laptop. You can try it by writing your own statements. You can play around with it. You don't need to worry about breaking anything. So you just try it. And before we move on to our next content, let's have an exercise of all the queries we have learned. So this is a table of students. So we have student ID, we have first name, last name, email, and year. And we don't have complex constraints here. So just for simplicity. And as you can see, we have a lot of different students. And some students may, they have the student ID as the unique identifier, the primary key here. And some students, they could have the same family name or last name. So, and as you can see, some students are in year 1, some students are in year 2, year 4, and year 3. So let's quickly go through all the questions here. So the first, how can we list all the students whose ID is larger than 5? Whose student ID is larger than 5? How can we grab that? What we can do is we can select. Let's select everything. Let's just select every attribute because it doesn't specify what attribute should we select. So we just select everything from students. And we should have the where condition here. So what should be the where condition look like? So we should specify where student ID is larger than 5. This is very straightforward. So as you can see, all the students whose student ID is larger than 5 are selected in our query result. And let's move on to the second question here. So the second question is list all the students whose first name starts with letter A. So this is also quite straightforward. We can select from the students table where first name. We can use like, the keyword like. However, I prefer regular expressions. So this is how we select the students whose first name starts with letter A here. So let's run this. As you can see, we have selected all the students whose first name starts with the uppercase A. And let's move on to the third question here. So this is related to update. So how can we update 1 year for all students? Yeah. Yes. So what we can do is just remember for update we need to update the table of students, and we need to have the keyword set followed by a list of assignments. And the assignment could be a calculation process. So let's set year equals to year plus 1. So this is to increase 1 year. This is to add 1 year for all students. So since it's for all students, so we don't really need to have a where clause there. Or if you want, you can add where true. Oh, sorry, I forgot to select the table. So to show you the result, so we can select star from students. So as you can see, the number, you can see the change of number here. So every student is increased by 1 year. So this is how we do update. Next question is, how do we calculate the average year for all students? How do we calculate the average year for all students? Which operator should we use? We should use aggregation. And the aggregation operator here to use is average. What we can do is we can use average star for student average years from students. So as you can see, the average year for students is 2. It's just 2. And our next question is, how many students do we have for each year? So what should we use here for select? You can just tell me some keywords. Yes, count. Count is used to count the number of items inside a column. So what else? Can you give me some more keywords? Of course we need where, but what's after where? Group by, yes. We need group by because we want to look into the situation for each year. So we need to group the students by year. So let's do it. So what we can do is we can select count. We can count everything. And we can count every row actually. Count from students where. So we don't need where because actually we don't need where in this because we are doing it for all students. So we just need group by year. So this will give us the number of students in each year. Let's run it. Sorry, to make it display better, we can always we can always add many columns as we want in the query. So what we can do is we can select year to make it look better. So as you can see, we have 7 students in year 1. We have 2 students, year 2 students. We have 3 year 3 students, and we have 2 year 4 students. So this is how we calculate the number of students for each year. So we need group by. And our last question is a bit complex. So some students, they share the same family name. So what's the average year of the students for each unique family name? And we only want the student, because some family names are only some family names are only associated with one student. Some family names are associated with multiple students. So we want to only display the family names with multiple students. So this is a bit tricky here. So can you give me some keywords to use? Select average year, yes. And then group by last name, yes. So let's first do this. We can select average. Since we are trying to calculate the average year, so let's just calculate. Yeah, so let's select average year from students. And we can group by I forgot to type by. We can group by last name, and we can display the last name here to make it look better. So this will give us the average year of the students for each family name. But what we want is we only want the average where there are more than 2 students associated with the last name. So some last names, there's only 1 student having that last name. So we don't want that. So what can we do? So whenever we want to filter out something, we can use the where clause. So what's the condition to be used here? Yes. Actually, you can't simply use greater than. You have to use count here, because we want to find out which last name is associated with more than 1 student. So we have to use count. Where count last name is larger than 1. This is what we can do. Oh, sorry. No. Not allowed in where. Sorry. Where group by. Select from where. Sorry, let me think about it. Group by last name. Sorry. Oh, we can't use aggregation in where clause. So we can't count. We can't use count in where clause. So what can we do here? Actually, I just forgot what we should do, but I did it last night, and if I remember how to write this, I will do it. I will update it in the forum. And sorry about that. I forgot the correct answer, but I came up with the questions and answers. So I will figure that out and tell you after the class. Sorry about that, and I will keep you updated. And oh, it's already about 5:50. So we may not have enough time to cover views today, the concepts of views, and we will cover it on Thursday. And we will be covering the concepts of views, and we will be covering how do we query multiple tables. And I will answer you the questions for the last exercise on the forum. Stay updated. All right, and that's all for today's lecture.